So this is the second example of such a improper definite integral. Well, it's still definite in sort of, because we have limits, but it's, on the other hand, it's improper since the integration limits this time aren't even finite themselves. Now, just for you as an orientation, the graph of the corresponding integrand function, which is very well known, 1/1 plus x squared, is quite simple. You can easily see that. Just think of the differential being placed to the right, and then you have 1/1 plus x squared. It's easy to see that putting x equals 0, we have 1 on the y-axis. And it's also quite easy to see that this is a proper rational function, which means well, in this case, the numerator grade or degree equals 0, is constant, term is constant, while the denominator degree or grade equals 2. So it's obvious that the denominator term approaches infinity on both sides. Yeah, when x is growing, when the absolute value of x is growing, we have a growing value of the denominator, but the inverse of this growing number will approach 0. So that's an important prerequisite for the fact that this area again may be finite. Okay, and so also this area extends this time arbitrarily far to the right and to the left, but it gets arbitrarily narrow, thin, you could say, right? So now the procedure is similar. Even this is quite obviously an even function. So we can again split this into 2 times now limit of, again, well, I could say integral from 0 to infinity, but this time the problem is placed here, is positioned here. Since the 0 is no problem, it's fine. But we have to carefully, well, take a finite number b and then carefully look what happens if we let b approach infinity. So that's what we do. Well, this is quite famous. In every handbook you find that the primitive function of this 1/1 plus x squared term equals the arctangent of x, also called the inverse tangent of x, as we've already talked about. And this is, of course, to be used and then to be inserted from 0 to b. And we get 2 times now limit b approaching infinity of, let's insert b first, then we get arctangent of b, and then minus arctangent of 0. Now I don't have the place to also draw the graph of arctangent, but you all know meanwhile that it approaches positive pi/2 if the argument approaches positive infinity. The same holds analogously in the negative domain. Then it approaches negative pi/2. That's just a fact. While on the other hand, it's an odd function, and so the arctangent of 0 must surely be 0. Also, it's continuous. Okay, and so that means in the end we have 2 times pi/2, which is actually the Archimedes constant pi as a result. This is the whole area between the graph of this interesting rational function and the x-axis. I hope this is clear and enough for you to know about improper integrals for today.